Hi, welcome back everybody. Today we'll be talking about combinations in Algebra 2, and this is going to be the section after we did permutation before that in section 12.4. So to begin with, let's go ahead and define what is a combination. A combination is by creating a subset, just like permutation, where the order actually does not matter. So I came up with like a list of all the things that will differentiate between permutation versus combination. So here you can see on the left, that's where the permutation is, and on the right, that will be something that will be in terms of combination. So in the first example, you can see if I ask the question, how many different ways can you select 10 classes from to form a schedule with 6 periods? So in this case, what's happening is you are going to have 10 classes to choose from, and you need to create a schedule where you have 6 periods, period 1, period 2, period 3, 4, 5, and 6. So when you create that subset, the order actually does matter, and so that's the reason why it's going to be permutation. Now, in terms of how I would write this, according to the last section, we would usually denote this as 10p6. So that is going to be kind of like our setup, because out of the 10 classes, we're going to go ahead and select 6 of them. Now, I look at combination, and this time, if I worded the problem accordingly, how many ways can you select 10 classes, 6 classes, how many ways can you select from 10 classes, 6 classes to take? Note how the question over here for combination, when I'm selecting the 6 classes, the order actually does not matter. All I'm doing is I'm just selecting 6 classes. So you can see how within the subset, you are in a situation where the order actually doesn't matter. So that's what differentiates between combination and permutation. The way we're going to write this one is going to be 10c6. So that's how you can tell the difference right now between combination and permutation. Let's take another example just to make sure. In this case right here, for permutation, the question would then be asked, how many ways can you select from 21 cars each year for the next 10 years? Note again how when you're picking for the 10 cars, you have to worry about when are you going to pick it. Are you going to pick it the first year? What are you going to pick on the first year, then the second year, the third year, the fourth year, and so forth and so forth and so forth. So the order does matter in the subset, so that's why it's a permutation. And again, writing it in a notation, that's the same thing as permutation. That is going to be 21p10 in this scenario then. Whereas in combination, the problem would then be worded as how many ways can you select 21 cars, 10 to buy? So I don't really care about what type of car I'm getting. I just care that I'm going to go ahead and grab 10 of them. And the order, again, doesn't really matter in this case then. The notation for this one would then be 21c6. Now, as a conclusion, then we said that for permutation, when you select your subgroup, the order actually matters. So that's the difference between permutation. But whereas for combination, when you set up the subgroup right here, the order does not matter. So those are the two differentiations. Now, to look at how do we do this numerically, let's go ahead and look at the following example over here. How many 3-letter arrangements can you form with the letters A, B, C, and D? What I'm doing here is I am going to select 3 letters, and in terms of events, I guess we can look at it as 3 events. So 1 slash, another slash, and another slash. And in those events, I'm going to select letters. I can either choose A, B, or C, or D. And I need to let me change the problem right here so that it says without replacement, because then I can recognize that I am not going to use the letters once again. Okay, so this to me is a permutation, because when I select the 3 letters, the order actually does matter, because the letters C-A-B is then different from the letters A-B-C. So what we'll do is we'll just go ahead and write out all the permutations, so then you can see what the answer is going to be then. Now, the first one I can think of is going to be, as we said, A-B-C. And then another variation of it would then be ACB. Then after that, we can go ahead and say BAC as another one. And then we also have BCA. And then we also have CAB and also CBA. So that is 6 of them already. Now let's take another set. We can also have ABD, and then we also have ADB. We can have BAD, and then we also have BDA. And we have DAB, and then we also have DBA. So far looks like we have 12, so let's see if we can keep the ball rolling. Let's see, we can also have BCD, then we can have BDC, we can have CBD, we can also have CDB, and we can have DBC, and then we can also have oops, sorry, let me go ahead and change that. Erase this guy right here. We can also have DCB. And I keep writing different things than what I say, so that is my fault. I apologize for that one. So that's this piece. And let's see, am I missing anything else? Ah, yes, ACD. Then we have ADC. Then we have CAD. We have CDA. And finally, we have DAC, and then we have DCA. So you can see that there are a total of, looks like it's going to be 4 multiplied by 6. So that is a total of 24 different permutations then. So 24 different ways of doing this. Okay, so that's going to be our answers. Different ways. Now, how do we look at it using permutation from last time? Well, we said we can set up a slot just like what we have up here, where we fill in each slot with a certain number that represents how many ways we can do the arrangement. In the first slot, when you pick your first letter, you have 4 to choose from. We have A, B, C, or D. So I'm going to go ahead and write 4 right here. Then the second event, which is choosing the second letter, I will now only have 3 letters to choose from because we selected 1 already. So if you select A, for example, then you can't select the A anymore. Then you have to choose B, C, or D. Then the third event, when you choose the third letter, you can only have 2 letters to choose from because you have 1 less than the one before. So it's going to be 2 over here. Since all these events, I want them to occur one after the other, then that means we're going to be multiplying the 3 numbers by the 2 counting principle. So our answer is going to be 4 times 3 times 2, which is the same thing as 24, which is basically what we got. The notation for this in permutation is going to be 4p3, which is the same thing as what we just wrote over here. And from last time, we say that that's the same thing as 4 factorial divided by 3 minus 1 factorial. So that's going to give us now the answer that we see over here. Actually, the bottom part I messed up on. It's not supposed to be 3 minus 1. It's supposed to be 4 minus 3. So let me go ahead and make that quick change. So there it is. Okay, so 3 different variations of how do you get the permutation. Okay, now let's look at the same problem, but this time let's change the wording a little bit. This time I'm saying how many ways can you select 3 letters from the letters A, B, C, and D? So note the difference between the question that I just asked in black versus the question that I'm asking right now in red is that you're going to select 3 letters and the order actually doesn't matter. So what that means is, yes, I can go ahead and set up all the different variations that I have just like in the first piece, but to help us out a little bit, here's what I'm noticing then. According to my second question that I'm asking, all of these guys right here in the first row, those are going to be exactly the same thing, right? Because remember, I'm just selecting letters. I don't care what the orders are. Then all of the second row right here, that's going to be all the same thing. All of the third row right there, that's going to be the same thing. And all of the fourth rows right here, that's going to be the same thing. So in conclusion, then that means our answer is that there's not 24 different ways, but instead only 4 different ways. Okay, so one thing I'm noticing is that combination is basically a subset of permutation. And let me kind of write that down right here. Combination is a subset of permutation. Okay, so the big question is then, well, how do we get the answer without having to do all this extra step? Because you'll notice that I want to do this the fast way without having to, spend a lot of time to write out every single term. So what we'll do is we'll go ahead and derive the equation now for a combination. And that's what I have written down so far. And we're going to use this example to show us how it's done. Earlier, we said that the permutation equation, NPR, is supposed to be n factorial divided by n minus r factorial. In fact, that's what I used over here for this problem right here, and you can see that's how I got the 24. Now, from that, I need to find out what the combination equation is. And again, keep in mind that combination is a subset of permutation. So what that means is my formula for combination is most likely going to be the permutation equation, but I'm going to divide by something, right? I'm going to go ahead and divide by something. So let's go over here to see how that works out. In our example, you'll notice that the subsets right here that are all the same, well, there are 6 of the subsets. The way I see it is that, let's say, look at the first row right here, right? You have ABC, ACB, BAC, BCA, and then CAB, and then CBC. To me, that's really saying that, hey, you have 3 letters and you're selecting 3 letters. In other words, that's 3P3. So to relate that to what we've been doing so far, yes, combination, the answer is going to be the permutation equation. It's going to be n factorial over n minus r factorial. And then in addition to that, you're going to take that and then divide by the number of ways you can rearrange those letters. And the way it works is, in this scenario, it's going to be r, p, r, right? For each subset, you have to select r number of letters, and then you want to find out how many ways are there to rearrange them. So let's go ahead and clean up our equation, so then that way you can see a final clean formula. So let's see here. That is going to be n factorial over n minus r factorial. That's still the same thing. RPR, well, RPR, that is going to be the following. R factorial divided by r minus r factorial. So cleaning that up once again, because remember, our PR, we're just using the permutation equation. That's how that came about. So now to clean this up, r minus r factorial, remember that right there is equal to 0 factorial, which in turn is equal to 1. Again, back into the factorial part, remember how I said that 0 factorial is actually important? Well, now we're actually going to see the use of it. So finally, cleaning up the equation that we have, it's n factorial divided by n minus r factorial. And the r factorial extra, well, that's where it's going to go into the denominator. So right there, that's my combination equation then. And hopefully for some of you guys, this actually looks somewhat familiar too, because now if you think about the binomial expansion that we did, this is the same thing as saying n choose r. Right? And choose r. That was the terminology that I used back then when we did the binomial expansion. So now you can see how things are starting to tie up then. All right, so let's go ahead and try it now with a few of these examples of combination. So the first one here is, how many ways are there to select 20 girls? Let's see, 6 to be girlfriends. So first you wanted to ask yourself, is this combination or is this permutation? The best way to determine that is think about how you're selecting the 6 girls. Does it really matter who you choose first or who you choose second or who you choose third? If the answer is yes, then it's permutation. But if the answer is no, then it's going to be combination. And to me, this doesn't matter how you select the girls or when you select the girls. Everybody's going to be the same side check, so don't worry about that. So to me, this is a combination problem. So what I'm asked to solve for is 10C6. Or the way we can write it is 10 choose 6, right? Either one of those notations should be okay. Now we just have to write it out, and then that's going to be our answer then. So it's going to be 10 factorial divided by 6 factorial multiplied by 4 factorial. Easy way to recognize how this equation works is that the denominator, the sum of those two numbers that are in the factorial, should also be equal to whatever is in the numerator. 6 plus 4 is equal to 10. Okay. So that right there now is just a calculator work. We can show that quickly. Let me go to calculator right here, and let's go ahead and pull up the probability part. Oops, sorry about that. Let's see, probability, and I want to go ahead and use NCR. So right here, we're going to go ahead and put 10, and then afterward, we're going to go ahead and put 4 Oh wait, actually we said 6, right? But actually it doesn't really matter which one because they're both the same thing. So 210 is the answer. And let me just go ahead and rewrite it one more time. This time I'm going to go ahead and use 10C4, and you can see that, yeah, it's exactly the same answer. So that bottom number, again, it doesn't really matter which one of those two is it. So let's see, back to where we were. So the answer is 210 different ways then, or 210 ways. Okay. Now, second part. How many poker hands, 5 cards, are with a standard deck? How many poker hands with a standard deck with 52 cards? Oh, I definitely cannot write questions. I'm supposed to ask how many different poker hands can you have or can you get with a standard 52 card deck? So what's happening is you have 52 cards in a deck and you're going to select 5 of them to create a poker hand. That's really what I'm trying to say. I'll work on my English in the future. So order doesn't matter when you pick those 5 cards, meaning like, you know, when you get like, say, for example, a full house, does it really matter like when you get it? Is it going to make a difference if you get AAA and then 2-2 versus 2-2 and then AAA? The answer is no. So the subset, the order does not matter. So again, that's going to be a combination setup. So the setup is going to be out of the 52 cards, I'm going to go ahead and choose, that's one way we can think about combination, 5 cards then, so 52C5. Or once again, we can go ahead and write it as 52 and then choose 5 just like this. So whatever notation works best for you. The answer will then be equal to 52 factorial divided by 5 factorial multiplied by 47 factorial, because 47 plus 52 is equal to, 47 plus 5 is equal to 52. So we're going to go ahead and throw that into the calculator. So let's see what we get. Let's see. Oops, now I don't want to sign out. So second, enter. And let's change that into a 52, whereas I'm going to change this into a 5, so it should be a pretty big number right there. So 2598960. 2598960. So that is the total number of ways that you can have different variations of poker hands. And keep in mind that these poker hands, they don't necessarily mean like poker hand, like full house, straight flush. It could be just a dud hand, for example. Okay. So 2 million somewhat ways. Okay, so let's now look at something a little bit more difficult then. This time I'm saying that there are 8 boys and 10 girls in your class. How many ways are there to select 6 to be at your period party? So this, again, very beginning, we're going to decide if this is a combination or permutation. And most likely, again, because we're in the combination section, it is going to be a combination case. When you select these 6 people, it doesn't matter how you select them, when you select them, they're all going to just come to your party. So again, this is why it's a combination. So numerically, let's see, let's write this out. We are looking at a total of 18 people because there are 8 boys and 10 girls. So then that means that out of the 18 people or the 18 students that are in the class, you're going to go ahead and choose 6 of them to be at your party. So 18C6 or 18 choose 6, depending on how you look at it. So that is going to be our setup, which is now 18 factorial over 6 factorial multiplied by 12 factorial. Okay. So I'm going to go ahead and leave that in this form because, again, you know, putting in the calculator, that's not too bad. I'll leave that part for you. Now, the next piece says, how many ways are there to select 4 girls and 2 boys to form the 6 to be at your party? So notice how this time, the way that it's worded, I am going to think about the subgroup. Now, the subgroup, I need to make sure that out of the 6 people, 4 are girls and 2 are boys. The problem itself does not say anything about order still. Okay, let me repeat it one more time. The problem itself, when you create the subgroup, still does not say anything about the order, meaning that I don't care how you select the girls, so long as there are 4 girls out of the 6 in the group, and the other 2 are going to be boys. So that tells me that yes, it is going to be a combination, but the combination setup for this one is a little bit different. So let's go ahead and isolate what we have. I want to have 4 girls. There are 10 girls to select from. So for that part, I'm looking at the following: 10C4. Okay, because that right there is saying that out of the 10 girls, I want to select 4 of them. Okay, so that's basically my first condition. Then we also have, I want to select 2 boys, and there are 8 of them, so that's going to be 8C2. Okay, so this part right here, that's saying that you have the 8 boys, and I am going to select 2 of them. And both of these events I want to happen again simultaneously, or actually more like one after the other. So that means by the 2 count principle, I'm going to multiply those 2 as my answer. So whatever you get in the calculator for 10C4 and whatever you get on the calculator for 8C2, multiply those 2 together, and that's going to be your answer then. So let's see, let me just go ahead and do it one time for you on the, I guess the calculator, just to see what we get. So here, let's write that out. So go ahead and clear. So 10C, and we said 4, and we're going to go ahead and multiply that by the math, and then we're going to go to probability again. And for this one, we said it's going to be 8C2. Okay, so that looks like it's going to be 5880. So let's go ahead and put that in as our answer then. Okay, so that's equal to 5880 ways. Okay, so hopefully these numbers are also still kind of like telling you a story too, because if you notice that the 10 and the 8 right here, the sum of those two, that gives you the total number of people that are in the party, or the number of people that you can choose from. But whereas the 4 and the 2 right here, right, those two added together tells you that there are still 6 students that you want to select from. Okay. Now, part C, what is the probability of part B if you select the group randomly? So that means that part B is going to be part of my answer, and I want to figure out what is the probability. Well, probability, right, the probability of this happening is supposed to be the number of ways that you can have this happen divided by the total number of ways that are available. Okay, so we're looking at kind of like, say, the total number of ways that this could happen divided by the total of number of ways possible. So what that means is I need to, first of all, then set up a fraction where the numerator represents what I want. Well, what I want is part B, so that's going to be 10C4 multiplied by 8C2. Whereas the denominator is representing the total number of ways that you can set this up. Well, that's where part A actually comes into play, because if you remember, that's how many different ways are there to select 6 people to be at your party. So that is going to be equal to 18C6. So if you take one answer, divide by the other, and then we're good to go then. So it doesn't look like I can avoid this, so we actually have to put in 18C6. So let's go ahead and do that right now. So let's see, math once again. And oops, sorry, math. And we're going to go ahead and put in 18, and then that's going to be 6. So that is going to be our answer. And remember, that's supposed to be the denominator, whereas the answer above, 10C4 multiplied by 8C2, that's the answer in the numerator. So we're going to take our numerator and then divide it by our denominator, and that would then give us the percentage then. So it's approximately, looks like 31.67% then. Okay, so that is going to be our answer. So 31.67%. All right. Okay, so let's look at the case over here. Let's see, what is the probability that you will have at most 1 boy at your party out of the 6 if you were to choose your group randomly? So again, we're looking at this as a probability problem. So I need to look at all the possible scenario in this case, right? I want to find out the probability of having at most 1 boy. So let's go ahead and say the following. I want to solve for P of at most 1 boy. So that means that the number of boys has to be less than or equal to 1. So for something like this, I think we can probably look at the case of each one and add the 2 together. So this is, let's see, the probability of boys less than or equal to 1. So there are really only 2 cases. That means that this is going to be the probability of having 0 boys, right, and 6 girls. then you can also have the probability of having exactly 1 boy and 5 girls. So those are the only 2 cases that fall into this category. Now, because this is going to be one or the other, then that means that we're going to have to add the 2 together in this case, because again, the word or in the 2 counting principle means that we have to do an addition. It's not where we have to have this and then the other one. Well, the setup then will then be the something just like part C over here. So let's see. The probability of 0 boys and 6 girls. So that means as a setup, let's see. We said earlier there were how many boys? We have a total of 8 boys. So out of the 8 boys, I am going to go ahead and choose 0 of them, right? 8C0. Then we have, how many girls do we say we have? We have 10 girls. So then 10, we're going to go ahead and choose 6. So 10C6. We want both the events to happen. So that means it's going to be and then. That's why it's multiplied. And we're going to divide all that by, remember, the total number of events, which is going to be 18C6. Okay. Keep in mind once again that I'm doing this correctly, because if you look at the numbers, it should tell you a story, right? The 8 right here, the 10 right here, and the 18 right here, those two 8 and 10 should be the sum of 18, because there are 8 boys to select from and 10 girls to select from, and a total of 18 students. And at the same time, right, the 0 right here and the 6 right here added together should be equal to the 6 that's down here, because I want to have 0 boys and 6 girls in total make up 6 in the party. Okay. Now I'm going to take that and add it with the next part and see if you can solve for this. Try to maybe pause the video and try for yourself and set it up and then come back. Well, let's go ahead and put it in, assuming that you tried that. So I'm looking at 8C1 multiplied by 10C5, all divided by 18C6. Okay, so whatever you get right here, you're going to plug into your calculator. And again, I hope that you can find the combination key, because that'll make it a lot easier for you when you solve on the calculator. So figure out what that is, and then that should be your answer. Okay. All right, here's the last example. How many ways can you select randomly 6 people? Okay, so we're still selecting 6 people for the party, where Jordan is one of them. Now, this question is a little vague in a way, because for one thing I can think of is, Jordan, is that a boy or is that a girl? And how is that going to play into all of this? Well, it turns out that it actually doesn't really matter if Jordan is a boy or a girl. And in fact, I chose the name Jordan because it is a unisex name, right? We don't know if it's a boy or a girl, and we actually don't care if it's either or. Here's what I do care about. How many people are named Jordan and how many people are not named Jordan? To me, I am going to select 1 Jordan out of 1 Jordan. So that means it's going to be 1C1. So that part right there, that is to select, okay, 1 Jordan out of 1 Jordan. Okay, so that's going to be the 1C1. And again, it's 1C1 because I don't care how I select the person, so long as I select the person. Now, you still have to select 5 other people in the party. I don't care who they are, just so long as you select them and their name is not Jordan. Well, the fortunate thing is that, hopefully anyways, there are no other Jordans. So then that means how many people are there left in the class to select from? You have 18 total, so I do believe that there are 17 left. And out of the 17, now you are going to select 5 more to form your group. All again, divide by the total number of ways you can do this. So that's 18C6. So part E, basically over here, what I did was I kind of threw a curveball, because I don't care, again, if this person named Jordan is a boy or a girl. Instead, we're just going to change it around so that we're looking at if the person's name is Jordan or not Jordan, and then set up our combination accordingly. So there you go. So that's what you're going to put into your calculator then. All right, so thank you for watching. I will see you guys next time, and hopefully you picked up some stuff. Okay, have a good one.